Welcome once more to Bawashli Electric. Secondly, again in Proteus. So today you're just gonna see how to deal with a ULN2003 IC. As you see in the picture here, this is the real IC in rear view, as you see, and this is the code ULN something XYZ. So this is the pin configuration of the pin 1, 2, 3, 4, 5, 6, and 7. Those are inputs. It uses TTL inputs. That is the TTL input, logic input, or 5 volts input. Then pin 8 is the ground, and pin 9 is the VCC or common. Luckily enough, it supports up to 50 volts. So that means here we have 10, 11, 12, 13, 14, 15, and 16. Those are outputs. They can output from 5 to 50 volts, and the current it outputs up to 500 milliamps per output. That means input 1 corresponds with the output 16, input 2 corresponds with the output 15, like that, and 8 is the ground, and 9 is the VCC. That is from 5 to 50 volts. Thank you. Just as you see the same here. So we're gonna see how this chip works. We're just gonna use it for some simple chip, for some simple purpose. We're gonna power on some higher volts relay, such as 24 volts relay, using 5 volts logic, maybe from a microcontroller or something of the kind. Then we are going to see the simulation. After the simulation, please watch the video up to the end. We are going to see a PCB schematic. After schematic, we see how to come up with the GABA file, and we upload it, and we have our PCB brought for assembly. So let's go. We are going to use Proteus once more. Just gonna come and open your Proteus software. So there we go. Just a quick through. Yeah, Proteus. The main purpose of a Proteus software is to carry out electronics simulation, do schematics or diagrams, then also some added PCB design, yeah, among others. So we are going to come here right away, schematic. When you try to peruse through this Proteus faster, we have open new. This is a new project. This is opening already existing project. This is save. This is home. This is schematics. This is PCB. This is 3D design, and like that. So we're gonna go into schematic. Just click schematic. So there we're gonna have our schematic. This is our schematic work page. So here we have, when you click here, we have side buttons. Here we have, this is select mode. When you have gadgets in the workspace here, to select them, this is device mode, this is junction mode, this is wire label mode, text script mode, bus mode, among others. So just come here to component mode, then you click P. So the very first chip that we're gonna use is the ULN2003, and we're gonna choose that one, ULN2003A, almost the same. So as I told you earlier, it must be having the schematic model as well as the PCB preview or the footprint, in case you aim at making a PCB design with it. Thank you. Now click OK. You just double click here, it is going to add itself here. Then we are going to have relay. Just move through. Now, since we are going to do a simulation, please members, you have to select the component that I'm exactly selecting in case you are watching for trial. So here relay, we have animated relay module. I'm gonna use that one. It has a footprint. So yours may not have a footprint. I'm gonna show you how you add a footprint. You say OK. Oh, I've said OK, but I'm still adding more components. Just going to click P here. I'm going to have something like, we're gonna have LED, and for LED I'm gonna have green. LED green animated, has a footprint. That's okay. Just gonna double click. We're gonna add select there. Then I'm gonna have something like 1 kilo ohm resistor. Just gonna type resistor 1K. Yeah, just gonna take that one. What else? For now, I'm gonna have battery for simulation. I'm just gonna have battery device multi cell, double click that one. But the battery is not going to appear on the PCB design. What is going to appear on the PCB design is we're gonna use, so you're going to type in pitch header block. So the pitch header block we are going to use, you are going to double click on 2 and also double click on 3. Let me try to see to peruse through the components. I think that's all what we need for now. Thank you. We're gonna need something else. We're gonna call it logic what? We shall have logic toggle. I'm gonna double click this one. You're gonna see it is function. Thank you. Now we come back the workflow, our schematic workflow. Oh, it is already adding when I was telling it to add. Okay, so this is our workspace. I'm gonna start by adding the relays so that we can see how we can manage our space. So I'm gonna add this one. Just gonna rotate it around. So I'm going to give it 24 volts. A relay 1, okay. So I'm just gonna Control C, since I don't want to over rotate. I'm going to copy to clipboard. I'm going to, okay, let's just place one by one. I need at least a maximum of 7 relays. I'm gonna tell you why I need 7 of them. That is 3, that is 4, 5, 6, 7. Thank you. Then I'm just gonna come here in select mode. I'm gonna select this one. I'm gonna give 24 volts. Each 24 volts. I'm done. Mine all are 24 volts. So I'm just gonna rotate all of them. I'm gonna rotate. Done. Just done with arranging them. Nothing much. Relay 1 up to relay 7. So I'm gonna add, after I'm gonna add our LED red green. Where I'm gonna put there, and on the cathode, and on the cathode, and on the cathode. Select mode. So you're gonna rotate 180 degrees all of them, so that anode is down, cathode is up. After arrange all anodes down and the cathodes up, we're gonna have our IC, and that is your ULN. Gonna place it there. Just gonna rotate it 90 degrees. Thank you. Yep. So remember, I told you 1, 2, 3 up to 7 inputs, then 10, 11, 12, 13 up to 16 is the outputs. Now I'm gonna let you know something here with you. When you come to this IC of Proteus, we have only the common, and as we said here, common, it is the VCC we give the positive power supply, and then ground is 8. But now in our Proteus IC there is no 8. That means the IC already, the software already gives it ground, so no need for giving it ground. Only what you need is to give the input and the output and the common, the VCC, which is going to be 24 volts for this case. So we're gonna have this is gonna be common, and we're gonna take it through all. It's gonna share the positive. Oh, sorry, I've forgotten the resistors, but I'm gonna put, let's have this 10 kilowatt resistor. It's gonna be big. Gonna create some space. Just gonna come here to select mode. Gonna select all these and move a bit down, something of the kind. Thank you. So I'm gonna put my resistors 1, 2, 3, 4, 5, 6 and 7. Just gonna rotate this. Yeah, I'm gonna just select this and say rotate about 90 degrees. Wow. Control Z. I'm gonna rotate one by one. Me, I'm done. I don't know for you whether you're done on it. So I'm gonna connect this one. I'm gonna connect all of them. I'm done. So also we're gonna connect this one positive. Connect it here. Positive around there. Positive. Do that all of them. Me, I'm done. I don't know for you what you're waiting for. So we are remaining with only completing something like from output 16 we're gonna have, oh, where is it going? Output 16 just trying to be systematic with my wiring. What's happening? Okay, that's why I'm gonna drop this one. I'm gonna change these wires so that they give me space. Lead green, I'm gonna remove it. I'm gonna show you just from this one, the last one. I'm gonna double click lead green, delete this one and just say okay, and it's all done, and come back to our wiring. Just gonna click this one and click something like this. Thank you. Then also this one, since here anode is receiving positive, you're gonna complete it with negative. We are going to do the same for all. Gonna have this one. With this one, me, I'm finishing. I don't know whether someone following me is also finishing. Okay, yeah, that's the wiring. Output remaining with input, then power supply, no problem. So input, we just gonna have this logic toggle to act as our inputs. It is a TTL logic input 0 and 1. Just gonna have 1, 2, 3, 4, 5, 6, 7. This one's only gonna help us in simulation. Then after simulation, PCB design, they're gonna have no function. Just I finished arranging mine, so I'm just gonna wire this one. To that input. To that input. So this one is signal source members. Just hoping maybe it is a microcontroller output of 5 volts. This one is just going to help us to do with the simulation to see if our circuit is going to be okay in case we make a board for it. So as you see, that is input and output done. What is remaining is power supply. And now power supply, for now, people allow me just borrow here some battery, and I'm gonna just change this battery from 9 to something like 24 volts and say okay. And now remember, I told you, if I just go here to device mode, select this one around here, then I'm going to move around here where ground. Just gonna come here, complete my battery with the ground. Then 24 volts is going to come here to common pin, and since it has come to common pin, it is also going to supply, as we looped the anodes and these other coils of the relay. So I'm just gonna have this one, my battery, I'm gonna have it linked there with the earthing. Don't forget that one. Thank you. So I think now we are done with the schematic capture or schematic drawing. These ones are our 5 volts or TTL logic inputs. This is our power supply, 24 volts. Remember, we are going to control. The main purpose of this is just to learn how to use this IC man here, the ULN2003A. And as I told you, these are inputs and these are outputs. As I showed you earlier, please feel that's the internal circuit of that IC, that yellow thing you see there. So now here we are going to go into our simulation. This is just say this relay, you can put in a value, just put here 1 kilo ohms resistor. I've used 24 volts relay. I'm going to control them with the 5 volts signal, and from now I'm just gonna click here simulation. Wow, animating. So just wanna increase so that members you can see something very nice. I don't know how I'm gonna make it. Okay, but I know you have to analyze here the relay where the positions are. So when I click here 1, you see the LED lights, and here the relay has changed the position. You see it is not like this one. It's not like this one. When I click this one also, when I click this one, and I click this one, you see, when I click this one, when I click this one, when I click this one. So that means when you have our PCB and we have here the inputs as 5 volt signal or TTL logic, it is going to help us control our 24 volts relay output. And in the relay output, we can control anything. Can control a motor, can control an alarm, we can control lights, we can control anything you'd wish to control. Any power DC bit AC, you can control it using our master chip IC, which is as very cheap as it is cheap. That's what you should know. Using that IC, we control high power using the signals. So now what next? That is the simulation is done. When I power off, you see, when I power off, when I power off, when I power off, power off, power off, power off. So when we are designing, a PCB, or when you're going to make PCB design, remember 5 volts signal does not be on the PCB. That means we shall just put their pins or headers where we shall be connecting the 5 volts. Also, the battery does not be on the PCB. We just need that header to be controlling the to put the 24 volts for our relays. Then also we shall put the headers for our relays in case we want to control. We want our relay to control something else, maybe a motor or XYZ. So allow me, I'm gonna remove this. I'm gonna just highlight this, or first stop simulation. Then I'm just gonna highlight this, and I'm gonna say here cancel. I'm gonna remove the battery, say here cancel. Yeah, the rest they are going to remain, only that I'm just going to reduce them down a bit so that I get the space to put the headers for the relay. Yeah. Thank you. So where the headers for the relay we have here, remember our relay has common, has normally closed and normally open. Just gonna use, do I have something? Come here to component mode. I have seal 1000. I have a pitch header here. I'm gonna place one here. This is junction 1. I'm gonna have here junction 2. I'm gonna have junction 3, junction 4, junction 5, junction 6, junction 7. And now members, why I said I want 7 relays. You can use one relay, you can use 2 or 4. I wanted 7 because just our IC has 7 outputs and just wanted to use all of them. But I want to use maximum power, maximum use of my money, you know. So I'm just gonna rotate this one, or not that direction, like that. Just gonna face down all of them. Thanks for being patient, but me, I'm done. So what I'm gonna do, I'm just gonna connect them. Gonna make 3 common, then I'm gonna make 2 normally closed. I'm gonna make 1 normally open. As simple as that for everything. Woo, me, I'm done. Thanks for being patient. I'm just gonna show you with these remaining few. Yeah, just add up. Just add up. I think also the connector, so we are remaining the connectors for this side. Yep, and we have for power jack, I'm just gonna use 2. Then I'm gonna need how many? 7. Or I'm gonna have for 3. Okay, I'm gonna use 2, 2. 1, 2, 3, 4. Hey, that's 1, 2, 3, 4, 5, 6, 7, and 8. Those ones gonna work, no pro. So I'm just gonna rotate them to look at the other side like that. To look the other side like that. I'm done with arranging. Now in the connection, what I didn't tell you with this ULN, it gives it is an NPN channel IC. It is an array of transistors inside their NPN transistors. So when you're making your circuit, please don't forget to consider that. Thank you. Okay, so I'm gonna connect these ones too. Yeah, 1 is going to remain, no problem. So that will be the input side, and this one is shall have here positive and negative. So this one shall just come here, and we shall have ground. Okay, can do like this, ground. I'm going to, where did I get ground last time? So somewhere. I saw the nice one. Yeah, it is here. So I'm gonna just get it. So this is ground, but on PCB this one is not gonna appear on the PCB, so I think even no need for putting, just delete. Only we shall do the naming. This will be ground, and this one is ground. Yeah, and this one 1 2 3 4 5 6 7 inputs, that's 5 volts, and this is our 24 volts inputs, and this is our output side. So schematic capture is done. People, don't forget to do this one, save project, because your project can crash at any time. And yeah, so what can we say? I can save mine, ULN2003A. what? Okay, just wanna leave like that. So can save what you feel like, it will be okay. So here we can't do simulation. Why? Because we don't have the power supply. We have removed the power supplies, we have replaced with the pin, since now our aim is to make circuit board. Thank you. So now we're gonna go to PCB layout. Thank you. So after having PCB layout, we have all these components are here. Yeah, and this blue frame is where our components have to fit. So I'm just gonna first come here to technology, set board properties. I'm just gonna increase my maximum board. I'm gonna increase it properly. It was 12. I'm gonna give this one something like 30, and this one I'm gonna give something like 20 inches maximum. It is not what you are going to use, but it has to be the maximum. Say okay. So just gonna have to print. Now what we do next is to insert the components, and if you want your work to look neater, you just have to arrange maybe the way you arranged exactly in the schematic capture. You start from junctions J1 up to J7, and that is J1. Come here to component mode. Don't forget. Oh, we start from J1. It is very small. Okay, I'm just come here to technology, set body properties, go back to 12 by 10. Well, value for maximum wages is not even valid. It's supposed to be inch. It is n. There is I missing, small I missing. Say okay, just increase. Then when I have my J, quite a small, but let's first do with that. We shall solve the issue later and increase a bit. So we have J1. Have J2, I have J3. Yeah, so after arranging my junction pin headers, so I'm gonna go to relay. I'm gonna put relay 1, relay 2, relay 3, relay 4, relay 5. I'm gonna put relay 7, 6 and 7. Then I'm gonna just make them come select mode. I'm gonna rotate each of them slowly as I arrange them. It's quite hectic, but it is simple. Just drag and drop. I've finished arranging my relays. Oh shit, this side at least should face down, because here the commons are receiving XYZ. So I'm gonna change this normally open and normally close to face up, and these ones they face down. What I'm gonna do, I'm just gonna click here. This one just rotate 180. Simple as that. Now when you see these lines here, they are crossing. What I'm gonna do, I'm just gonna click here X mirror, click here X mirror, click here. All of them, just I'm gonna mirror them. Just like that. What's happening? No, press Ctrl Z. Don't mirror, please. It's going fine. It is on our way out. So what next? We look at the schematic capture. We have placed these junctions, we have placed these relays. So let's place the resistors and the diodes. We start with R1. There we go. Come to component mode, start with R1. What? This resistor is big. Okay, no problem. Just gonna rotate it something like this. Let me first see 3D view of this. What? It's long. Oh my god. Okay, this is for study purpose, no problem. Resistor 2. I've finished arranging my resistors from 1 up 7. I don't know the one who is watching what is after, but they seem to be very long. Okay, no problem. So we're gonna go next to diode 1, that's lead. This one, just gonna place it. Let me check around here. I'm gonna find a way of organizing this one. Yeah, I'm gonna place it somewhere. I'm gonna place them under this kind of placings. So that's that one. I'm gonna have that 2. Why is this one connecting with the resistor 7? It has to connect with the resistor 2. What's happening? Let me check. Diode 1, this is diode 7. No. It's diode 1. This is diode 2. Don't mind. This is diode 3. Okay, this is DAD 4. This is DAD 5. This is DAD 6. Okay, this is DAD 7. Diode, that is light emitting diode, but is a LED or a bulb in simple terms. Okay, so PCB layout not yet changed. Schematic capture file, save project. 1 2 3 4 5 6 7. This is DAD 7. DAD 7. Let me check. DAD 7, relay 7, resistor 7, and relay 7. What's happening? 1 2 3 4 5 6 7. Okay, this is 2. Okay, what problem? I'm gonna delete that first, so I'm gonna put that to yeah. Okay, now I'm just gonna place all of them as you watch. I'm done. Diode 1, diode 2, LED 3, LED 4, LED 5, LED 6, LED 7, and there are 7. So when you come to our schematic, we are finished with all the upper part. Now going to our IC, and that is this one. So I'm just gonna place it around here. Yeah, then after that we have our J 8 9 10 11 and 12. So come to PCB layout, say J8. Is this side what are here? J8, J9, 10, 11. They are finished. Just gonna arrange these ones. Yeah, there we go. So we have properly placed our components. So what we are remaining, we are going to come here and just gonna click this one and click board edge, and we draw our PCB. Something like that. Let's try to see the 3D of the things. Wow. Oh. Okay. So much is spaced. So much spacing, but the resistors are very wrong, my dear. So we have these are the inputs, and these are the inputs. This is the IC, the resistor, the outputs, the relays, and these are the LEDs. So just gonna make something very neat here. Just gonna extend a bit. gonna reduce this one a bit. Yeah, we are coming to something reasonable. So I think there we go. Now what is remaining? These components of ours, they have no connection. Are you seeing? There is no any connection between the components when you remove the component view. That is what it is. So now we have to come to PCB layout and do one more thing that is remaining, and that one is the connection. So we are going to come here to design role manager first. We are going to say net class power. We have power default. I'm going to have here next style. Just gonna have something like T next style, something like T25, then V30, something like T30. Okay, here I'm gonna have bottom copper, then signal I'm gonna have something like T20 and V20. Yeah, bottom copper. I'm gonna say okay. Come to tools, technology, set layer pairs. Yeah, set bottom copper, say okay. Come to auto router, try out auto router 10%. Just begin auto routing. It's trying to look for where to pass the cables, the connectors. Oh, it is failing. It is taking time looking for how to connect the components. Wow, I think they are all finished. Nothing is missing. Nothing is missing. Wow. Let's check the 3D layout. So when we place our components back, when we view from behind, you will see that our components are properly connected. So you have here side view. I see. That is proper connection of our circuit board. And when we have the other side, that is the proper way how we are seeing our components. So just gonna do some little labeling here. Just come here and say top select, then write something here. Let's write Bawashir. Center, just gonna make it default font, not default, just gonna make times. Times New Roman, just simple. Gonna make it bold italic. Gonna say yes. Height. Gonna increase something. global style, strike through, underline. Here too. What? No, it's 0 point something like 3. Okay, 0 point something like 2. Okay, yeah. I've tried some little namings when you come to 3D design. Oh, okay. So I was trying to save, just named this, tried to make some namings. So it's been 7 from 1, 2, 3, 4, 5, 6 up to 7. 5 volts input. This is 5 volts input, 1 7. That's what it tells us. This is Bawashil Electric, the company that makes. Okay, it's not generally a company. Here we have relay output, normally open, normally closed, common, normally open, normally closed, common for every relay. So I think this is PCB design or layout is finished. We have here schematic capture also is finished. Then we have the 3D view. So the 3D view, when you have here front view, that is how it appears. So we can zoom in a bit and see. So as you see the namings, here is the relay output. We have normally open, normally closed, and common. Then down this way we have 5 volts input. Here we have 24 volts and ground. Here we have ground. Then we have 1, 2, 3, 4, 5, 6, and 7. So that is our PCB is final. Here we have Bawashil Electric. When we see the behind view, the connection is already made, though the connections are thick. I just wanted to make a quick routing. So auto routing is easier when those connections are thin, because they can easily find their path to each component. Thanks for watching. See you when you see me. That has been our ULN2003A relay, how to use it, and you can use it with various applications. Bawashil Electric, see you when you see me.